This presentation, entitled Who Shot the Deer? Elemental Analysis at the Meyers Springs Pictograph Site, was given at the 2019 American Rock Art Research Association's annual conference in Flagstaff, Arizona. And this research was published under a slightly different name, the one I have updated on this slide, Portable X-ray Fluorescence Analyses at the Meyers Springs Pictograph Site, in the 2020 American Indian Rock Art volume that should be coming out soon. Hello, my name is Karen Steelman, and I will be talking about recent documentation and research that we conducted in March of 2019 at the Meyers Springs site in Terrell County in southwest Texas. For those of you who don't know me, I'm a chemist, and my research focuses on radiocarbon dating rock art, as well as pigment analysis. I use chemistry to study rock art. For this presentation, I'll be talking about the use of portable X-ray fluorescence spectroscopy to analyze both mineral pigments as well as damage to the site by gunshot impacts. I am the science director at Shumla Archaeological Research and Education Center. We are a nonprofit dedicated to studying the rock art of the Lower Pecos in southwest Texas via documentation, research, stewardship, and education. While I live and work in southwest Texas, I'm also interested in collaborating on new projects with others around the world. So if anyone's listening and is interested in collaboration, please send me an email. So first, let me introduce you to the Meyers Springs site. There's a large burned rock midden in front of the site, and there's many bedrock mortars both in front of the shelter and also found on the uplands above the main rock art panel. The site boundary is actually quite extensive. Here you can see in the distance a historic period dam that was built in 1901 to hold the spring water, and you can see the overflow running in front of the rock art panel. And we'll do absolutely anything we need to do to accurately record the rock art, including putting Jared, one of our archaeologists, in an inflatable boat, probably made for small kids. We renamed the boat the Art Explorer 3000, and we needed this to get close-up photographs of the imagery that's painted above the dam around the spring. The Meyers Springs site is known for its historic period pictographs, but is also the westernmost reaches of the Pecos River style. Here you can see a polychrome Pecos River style anthropomorph with a loaded atlatl in its right hand and a wrist adornment and extra darts in the left hand. And you can see the historic period pictographs painted superimposing this older Pecos River style painting. This past March, Shumla spent a week recording the Meyers Springs site as part of our Alexandria project. And in August 2017 is when we launched this level 1 baseline documentation project, which is publicly known as the Alexandria project. This four-year baseline documentation initiative is designed to conduct level 1 documentation for all known sites in the region, of which there are over 350 known rock art sites within Valverde County alone. So we're just going to focus on level 1 baseline documentation at the moment, and this includes filling out State of Texas archaeology forms, as well as our own internal rock art site form, conducting proper mapping with GPS, and some high-tech photography methods. We're also ranking sites according to site preservation, threatened status, and research value. And after this 4-year project is complete, we will start further research at those sites that are the most immediate. So here's Charles Koenig, project archaeologist, shown working on our rock art site form on a computer tablet. I'm actually getting to sit in a chair at a rock art site. Vicky, Amanda, and I were up close to the panel, taking detailed photographs and using D-Stretch on our phones so that we could point out details to Charles. And Amanda's taking a list of future photos that we're discussing in our notes so that we have photo documentation of those details. And then Charles, back from the panel, he has a different perspective, and he can see the overall relation of the images to each other. I believe this rock art site form for this site was over 30 pages of notes. For the photography at the site, we use 2 complementary techniques, one of which is called a gigapan. This is a regular DSLR camera with a nice lens that sits on a robotic gimbal system to take overlapping photographs from a single vantage point. You lose the shape of the shelter when you use this method, but you can get incredible resolution from the stitched image. These overlapping photographs are stitched together using a supercomputer to create one high-resolution image. We actually split this rock art panel into 14 sections so as to keep the detail of the rock art. We even had to set up the gigapan in the water for some of the sections, which is a very slippery undertaking. And as the landowner had given permission, we've made these images available to the public on the Gigapan website. And actually, there are hundreds of gigapans from the Alexandria project available for viewing, and we hope both the interested public as well as potential researchers and collaborators will view these images. And I'm not going to show it for time's sake, but one of the neatest things about this is that we can use D-Stretch to enhance the entire section of the panel, which really allows you to see how hard to see images are related to each other. So for an example of one panel section, here's a well-known image from the Meyers Springs site with a church and a priest figure. Zoom in. And we'll focus on this figure with a bow and arrow. And you can see the amazing resolution that we can obtain, even seeing brush strokes. The other photography technique that the archaeology team uses in tandem with Gigapan is to create a 3D model using software called Structure from Motion. You take overlapping photographs with a handheld camera and move across the panel following the shape of the rock shelter. These photographs are then processed with a supercomputer to create a 3D model that can be manipulated in space. You can get accurate measurements along the curved back wall from this technique, as well as share online what these 3-dimensional spaces actually look like. For those landowners who give permission, we also post these 3D models online on the Sketchfab website. These are really fun to manipulate, and I encourage you all to check these out. As amazing as our recording techniques that the team uses are, today I really want to focus on our use of portable X-ray fluorescence for pigment analysis and how we can use this spectroscopy technique in new and interesting ways to answer specific archaeological questions. Because the photography at the site required us to be at the Meyers Springs for an entire week, we were able to do some additional research at the site using portable X-ray fluorescence, or pXRF. This is an elemental analysis technique, and it has been applied to rock art as well as pottery and obsidian and other artifact types. As applied to rock art and analyzing thin paint layers, it's a semi-quantitative technique. Rock art presents a unique challenge to pXRF research because you're analyzing thin paint layers. Therefore, the data you get from the instrument is semi-quantitative. A big number means you have a lot, and a little number means you don't have very much, and researchers shouldn't get too invested in absolute numbers. What's great about the instrument is that it's handheld, weighs about 5 pounds, and can be put in your backpack and carried to a remote rock art site. And then you can analyze the paintings in situ. And it's a non-destructive technique, in that you're not taking a sample from the wall and taking it back to the laboratory. So there's some interesting research questions that we've been able to explore with pXRF, and that includes determining if black paintings were painted with charcoal or manganese pigment, confirming gunshot damage at a site, and we've been able to determine superimposition of red over black paintings even when we were unable to see the black paint underneath with photography or digital field microscopy. So how does it work? A pXRF instrument consists of an X-ray source and a solid-state detector at angles visible in the sampling window. Primary or incident X-rays come from that source, and they strike atoms in the analyte with sufficient energy to eject the lower inner shell electrons, which creates an unstable ion. When this occurs, an electron from a higher energy or an outer orbital fills the vacancy, releasing energy in the form of secondary or fluorescent X-rays. And the energy of any given secondary X-ray is characteristic of a specific element, allowing qualitative identification of elements present in a sample. So which element is it? Do you have iron or do you have manganese? What element is present? In addition, the detector also counts the intensity or the number of secondary X-rays from the sample, and this allows quantitative elemental concentrations to also be determined. To show you how pXRF data collection occurs in the field, we'll use the example of a possible gunshot location. And here we're going to use 60-second analysis times. So in this example, here, we found elevated lead levels. We did also detect arsenic, but researchers should be careful as there's an overlap between one of the lead peaks and one of the arsenic peaks, and the software incorrectly reports the presence of arsenic when it's not always there. So you actually need to look at the raw data. For paint samples, it's also useful to think about what you're actually analyzing with the pXRF instrument. For scale, this cross-section is about a half a centimeter wide. So the black paint layer is approximately 100 to 300 micrometers. From the instrument, the X-rays of the any element greater than titanium travels at least 200 micrometers. So the X-rays are traveling through the accretion layers, the paint, and even through part of the rock substrate. So you're seeing the elements present in that sort of larger sampling area and not just from the paint layer itself. So with rock art, because you're analyzing a thin layer of paint, there are several considerations that researchers in the field need to be aware of. And these are issues that will affect the quantitative results. Thickness of paint, analysis area, is it an infilled figure or a thin line, and so forth. These all combine to make the technique semi-quantitative at best, and really a qualitative analysis technique. Is the element present or not? We discussed these considerations in the application of pXRF to rock art research in this 2014 archaeometry publication, which is available on Schumla's website. In this previous study, we visited 10 rock art sites in the Lower Pecos, and we confirmed that the reds and yellows are made with an iron-based mineral, and that the Pecos River style black paintings are made with manganese mineral pigment, whereas some of the smaller black figures of an unknown style are made with charcoal pigments. I'm also very proud of another recent study using pXRF on mobillary or portable art in the Lower Pecos. And if anyone would like a copy of this article, it's still under embargo from the publisher, but if you'd like a copy, just send me an email, and I'd be glad to send you a copy of it. Again, let's get back to our pXRF analysis at Meyers Springs. It's really helpful to have at least 3 people collect the data. One is using the instrument, second is taking notes on a tablet, and a third is a photographer to get context photographs of the analysis locations. If you have another person, they can hold the laser pointer to show the exact location of the pXRF analysis in the photos. It helps to have a great team. Because we took so much data, it's very important to take good notes and keep track of analysis locations. Schumla uses electronic forms on tablets. Here's information about replicate measurements, superimpositioning, sampling area type, and so on. Which figures were analyzed, ID numbers. All this information is in the Schumla database that we have subsequently queried to answer research questions. We took 110 pXRF measurements at Meyers Springs. 11 of those are on suspected bullet impacts, 8 are on historic graffiti, and 36 are for historic period pictographs. In addition, we analyzed 55 areas of unpainted rock as controls for each of the analysis locations. These controls are very important for comparison of data. And at Meyers Springs, we had 3 main research questions. 1, can we confirm that bullet impacts, can we confirm those by the elemental presence of lead and other elements? 2, was the indigenous art of the historic period made with modern commercial paints or ochres as the prehistoric paints? And 3, are there any interesting chemical signatures in the historic graffiti? This site was a watering camp for the Seminole Scouts of the U.S. Cavalry in the early 1900s, and was also a favorite camp and picnic spot for early settlers in the area. So the gunshot damage that we see all across the panel is most likely due to early vandalism of the site. Some of the images were clearly used as target practice and have suffered significant damage. You see large fractured, spalled areas, as well as a black residue from the bullet impacts. When you analyze the black areas using the pXRF, we observe high levels of lead. For 11 suspected bullet impacts, this is the lead levels for those locations. I've actually plotted the control areas of unpainted rock backgrounds, but those levels are so low on this scale that you can't see them. Thus, we definitely have lead due to the bullet impacts. In addition, we have chromium, copper, selenium, cadmium, tin, and mercury found at lower levels. This is predominantly seen in the black residues, but even lead was often detected on the bare wall where fractured patterns were suspected to be due to bullet impacts. So pXRF is able to identify these suspected bullet impacts when you need confirmation that that is what is happening. At Meyers Springs, we also looked at 8 locations of historic graffiti. And here's some from the cavalry units stationed nearby. We also have this black historic graffiti with a date of 1896. So looking at the iron levels of the historic graffiti, the first 3 measurements are replicates of this red graffiti covered by a black water stain. It infers elevated iron. Next is elevated iron in the cavalry graffiti. Then elevated iron in 2 other names in red paint along the panel. So the red paint used in the graffiti is elevated in iron. We also looked at 2 instances of black historic graffiti. The one with the date of 1896 is significantly high in iron, highest reading we saw. But the last example is only slightly elevated, but this could be due to the thin paint layer that is remaining. Overall, it appears that the historic graffiti, both the red and black, is made with iron-based pigments. And remarkably, there were no elements that popped out as having been made with modern paint, such as lead, zinc, or titanium. So either they were made with locally sourced iron pigments, as the pictographs were, though that's only for the red pictographs, or they were made with a commercial lime-based paint and with iron added as a pigment, and I think that's much more likely. So now let's look at the data we collected from the historic pictographs. Images with crosses, horses, known historic age pictographs. For all hues of red, orange, and yellow, we saw elevated iron. And this is just zooming in to see some of those examples that are lower than some of them, but are also still very much elevated in iron. We saw elevated iron for all of the red and orange and yellow historic period pictographs. This is what we see for prehistoric art. And so there's no differences depending on the subject matter, church imagery versus bow and arrow or horse paintings. One white painting showed no elements to help identify the pigment. Though the pXRF that we were using does not see aluminum or silica, which would be present in a clay, which is what I suspect that the white was made with, but we haven't confirmed that. For the two black historic pictographs, manganese levels were significantly elevated in the 20,000 to 30,000 parts per million range, whereas the backgrounds were in the hundreds. This is what we have observed for Pecos River style pictographs, and demonstrates that these two black paintings were made with the manganese mineral pigment and not charcoal, and not iron like the black historic graffiti. Two yellow handprints and a bird-shield figure have elevated zinc and elevated iron. I'm very suspicious that this is a commercial zinc white with iron yellow added for color. This is perhaps the most interesting discovery made during our research here. So using pXRF, we've been able to do a non-destructive initial chemical survey of the paintings at Meyers Springs in really just a few afternoons of fieldwork as part of a larger documentation project. So it's really quite remarkable technology that I hope to see being used more and more at rock art sites. I'd like to thank the landowner, Thad Steele and family, as well as Greg Williams for helping facilitate access to the site. And as I make this recording in May of 2020, the team has recorded over 183 rock art sites with baseline documentation so far with the Alexandria project in the past a little over 2.5 years. It's a remarkable feat, and I'm really proud of them. And it's really these four, Vicki Roberts, Jared Roberts, Charles Koenig, and Amanda Castaneda, shown here, who are day in and day out going to each site, as well as spending days in front of computers to analyze the data. Charles and Amanda have left to go to Wyoming, so Charles is pursuing his PhD there, and now we have Audrey Lindsay and Tim Murphy also working with the team and documenting these sites. I'd like to thank Marvin Rowe for letting me borrow the pXRF instrument used in this study, and thank you for your attention. Be sure to check out the publication on this research in the upcoming 2020 volume of American Indian Rock Art. And if you have any questions, you can email me at ksteelman@shumla.org. And thanks.